All right, I wanted to go ahead and take a look at the practice exam solutions just to kind of guide you through some things and make sure you feel comfortable with the problems. So first, let's begin with problem number 1. And first, I want to do what everybody else did, which is awesome, which is I want to draw some free body diagrams. So for M1, I have a normal force on 1 pointing up, and I have the weight of M1 pointing downwards, and I have this tension T pulling it. For mass number 2, I have a tension pulling it, and I have its weight. Now, one thing I think that confused people is it says the acceleration of the blocks is 0.6 g, and I'm not sure what people thought, but for whatever reason they seem to overlook that letter g. And I want to just be clear that that is the acceleration due to gravity. So when we set up our equations for block 1, we're going to have that t equals m1 times its acceleration. And I'm just going to go ahead and actually put m1 times 0.6 g right here. And of course, there is the y equation that the normal force equals the weight. I know that. It's true. It's just not useful in this situation here. Now, the other thing I want to talk about is sign convention. The second mistake I saw people make when we were working on this yesterday. Okay, this is the motion of the system. So that means I'm going to make this direction positive. And if this direction is positive, that means gravity is positive and tension is negative. So that's going to give me a second equation, m2g minus t equals m2 times a. Keeping that in mind, that's going to be m2g minus tension equals m2 times 0.6 g. So when I get tension in terms of m2, that's going to lead me to the following conclusion. T is going to actually equal 0.4 times m2 times g. A small little note here. The incorrect answer for E, this is wrong, and it comes from writing T minus m2g equals m2a. So you've got to be really careful in that sign convention, just to be clear. Now let's get the ratio of the masses. And so I have two expressions for the tension, one here and one here. So I know that 0.6 m1g equals 0.4 m2g. I'll cancel out the g's. I'll divide both sides by m1. And I'll divide both sides by 0.4. And so 0.6 over 0.4, that's the same as 6 over 4, which is 3 halves, which is 1.5 equals m2 over m1. There we go. So that's question number 2. I'm going to try to do about 5 of these at a time in a video. I think that's about right. So for question number 3, oh my gosh, we want the change in momentum from this graph. Okay, let's just remember, impulse equals change in momentum. And this is just the area under the F versus T graph. So I'll go ahead and do that here. So that's going to be 1/2 of the base times the height, and that gives me 1/2 ft, which is C. Good for us. All right. Now for question number 4. A ball is struck at time t equals 0. And this is just parabolic motion or projectile motion. I mean, it is a parabola, but they say parabolic path, but this is just our projectile motion. setup. Now, it says which graph represents the horizontal component of the velocity. So these are all velocity graphs. Let's remember the horizontal component of the velocity, that is V naught cosine theta, and that, sorry, the horizontal component is V naught cosine theta, and that never changes, which is exactly what graph E is, right there. Now the vertical component, let's be clear, V initial in the y direction is going to be positive because it's up, and then Vy final is going to be negative as it goes down, and Vy equals 0 at the top because it's at the top and it's turning around. Well, graph D is the only graph that reflects that idea that you throw the ball up in the air with a positive velocity, it slows down to a speed of 0, and then accelerates going downwards. And if you notice, by the way, if they were to ask you, you know the slope of this graph is negative 9.8 meters per second squared, because the slope of the velocity graph is acceleration, but that's just an aside. All right, that's questions 1 through 5. We'll take a look at questions 6 through 10 in our next video.